Hello, this is a third lesson on chapter 8, operations on set. Okay, so there's a few funny things that we are going to do. It's not difficult, but you gotta have to pay attention to the details. So a union mean everything together. The union of two set A and B, denoted by A union B, is the set consisting of all element either in A or in B or in both A and B. The element must be at least in one set A or B. So basically, you look at set A, you take all set A. You look at set B, you take all set B. You put them all together into one set. That set is called the union. All right? So in terms of notation, A union B is all x's such that x is in A, x belong to A, or x belong to B. So you take everything in both sets and you pull them in together into one place. So first one we have, let's check it out, all right? Look at set A. You have the A, the B, and the C. In set B, you also see the B and the C, but you also see the D and the F. So you don't repeat whatever they have the same. You only list down the different elements that appear in both sets. So A union B would be A, little B, little C, little D, and little f. So you take them all, but you don't take the repeat. All right, let's take a look at the second one. Let's use a different color so it won't be confused. Number 2, in the C set, you have 1, 3, 7, 8. In the D set, you have 2, 5, 10, and they're all different. So C union D would be everything that you see. And it's nice to list them in order of increasing numbers. So I'm going to put the 1 first. I'm going to put the 2 second. I'm going to put the 3, then the 5, then the 7, then the 8, then the 10. You see? So I have 7 elements in my set right now. I had 4 in C, 3 in D. Together here I have 7 elements by combining all the different items all together. All right, next example. We have that, and that, and they're all different from these. So therefore, E union F is going to be all that symbol. We have the dollar, not the dollar, percentage sign, the dollar sign, the number sign, the A, the B, and the C. All in one place. Going to G. If you look at G set, all odd numbers. If you look at H, all even number. So G union H would be everything starting from 1, and it goes on forever. So that to me looks like the natural number, right? Because the natural number starts at 1 and it ends at infinity. So I'm going to write it down in red. G union H is all x's such that x belong to the natural number. That would be the best way to represent it. Or you can list it down as 1, 2, 3, 4, 5, and then you put a dot, 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 and then you close the set. That would be, this notation is listing the element. This notation is using notation. using mathematical symbol. All right, everybody's good? Let's go to the next definition. Intersection. Intersections of two sets. The intersection of set A and B, denoted by A intersect B. It's like an upside down U. Union is a U. Intersection is an upside down U. Is the set consists of element that is in A and also in B. So they are the elements that A and B have in common only. So all elements must be in both sets to be in the intersection. Okay? In the union, they only have to be in one set. They'll be in the union. In intersection, the element must be in both sets. So I am going to reduce my circle a little bit. That way I can actually isolate the members for you a lot easier. I think I'm going to go very small. All right, it's cool with this program. So take a look at set A and set B. Okay, in A you have A, B, C. In B you have B, C, D, F. So you can clearly see that A is here and A is also there. C is here and C is also there. But A is not in B. D is not in A. F is not in A. So therefore, the intersections of these two sets, A intersect B, will be just B and C. Only two things that are in both sets. You're with me, right? Okay. Let's move to the next question. C has 1, 3, 7, 8. D has 2, 5, 10. None of those are the same. Therefore, C intersect D would be an empty set. Nothing can be put in there. Or we can say it's equals to no. Okay, the intersection is going to be a null set. E, take a look at E. All right, E has this sign, percentage sign, the dollar sign, and the number sign. In F, we have A, B, and the number sign. So it shows that, hey, these number signs are the same. Those number signs are the same. Wow. So those are the signs that are in the intersection. Okay. So therefore, in the intersection set, you only have one element only. And that's that. Okay. Everybody all right? Okay. Next question. We have 1, 3, 5, 7. That's all odd. In H, we have 2, 4, 6, 8. That's all even. Odd and even aren't the same. So again, one more time, you have a null set, an empty set. Nothing is the same. Nothing in common. So that is a null set. We okay, right? All right, let's move on. Complement. Complement. If U is a universal set, the bigger set, then the set A, then any set A is a subset of U. So U is a bigger set, A is a dot in there. A is a subset of U. The complement of A, denoted by A bar, is the set consists of all elements in U but not in A. So, for example, I have this universal set. and I have an A in there. Everything that's outside of A is called A bar, complement of A. So basically U minus the set U minus the set A. Basically that's what it is. The set U minus the set A. Okay? All right. For example, for U equals to 1, 2, 3, 4, 5, 6, 7, 8. So let me illustrate it with a box. If I call that the universal set, it would have these elements: 1, 2, 3, 4, 5, 6, 7, 8. Those are the elements in the universal set. Find the complement of the given set. So they want me to find A bar. So I want you to listen for me for a minute. In A, you have 1. So that 1 is taken. That's belong to A. In A, you have 2. So 2 is taken. It belongs to A. In A, you have 8. 8 belong to A. Which mean these 3, 4, 5, 6, 7 belong to the complement of A. So A bar would be everything in U minus A. So it would be 3, 4, 5, 6, and 7. 3, 4, 5, 6, and 7. That would be A bar. Okay. Now I'm going to cross this out a minute, and I'm going to do it again. So there's my set. That's my universal set. Now I'm going to examine B, and I want to find B bar. All right. So in B, there's a 3. So that 3, oh, where's my 3 go? So the 3 is taken. It has a 5, so the 5 is taken. It has a 7, so the 7 is taken. Which means B bar, B complement, would be 1, 2, 4, 6, and 8. So 1, 2, 4, 6, and 8. Okay, so in the universal set, you have 8 numbers. B has 3 of those. Therefore, B bar would have 5 of the leftover. So you see, this one has 5 elements. That one has 3 elements. Together, they make up the 8 element that you have in the universal set. All right. Okay, let me erase this out. Oh, sorry. Erase this and redo it. So now I'm doing the third question. This is universal set. 1, 2, 3, 4, 5, 6, 7, 8. That universal set. Let's examine C. C has 4, so that 4 is gone. And a 6, so that 6 is gone. So the number 4 and the number 6 are gone, which means that everything else in there, 1, 2, 3, 5, 7, 8, are the elements in C bar, which is the complementary set of C. So it will consist of 1, 2, 3, 5, 7, and 8. So it has 6 elements. Together with the C has 2 elements. Together that would be 8 elements, and the same with 8 elements you have in the universal set. All right, everybody's good? Okay, let's move on. Example. Perform the given operation for the universal set that have 1, 2, 3, 4, 5, 6. A is 1, 2, 3, 6, and B is 1, 2, 6, C is 4, 5. We want to find out A intersect B in number 1, A intersect B, then union to C. So first thing first, just try to bear with me, okay? We are going to find A intersect B first. So what is A? A is 1, 2, 3, 6, correct? And B is 2, 4, 6, and C is 4 and 5. Take a minute to check things over. 1, 2, 3, 6, 2, 4, 6, and C is 4, 5. So first thing I want to do is I want to do A intersect B. A intersect B mean everything have to be in both A and B. And let's see. Things that are in both A and B would be the 2 and the 6. You see, 2 and 6 are both in A and B. So therefore, the set A intersect B would have just the 2 and the 6. Those are the only two numbers that in both set A and B. Then I'm going to put the set C right underneath here. C is 4 and 5. So now I want A union B. A intersect B union with C. So this union sign right here means everything in both sets. So I'm going to list. In A intersect B, I have 2 and 6. In C, I have 4 and 5. So to list them in order, 2, 4, 5, 6. Those 4 elements would be the answer to our question. And that would be the answer to A intersect B union with C. All right? It's not too bad, right? I'm going to try the second question with you and hopefully it becomes a little bit more clear. Second question, first we want A union B, then A union C, then we want the intersection between those two sets. Okay? So leaving the screen like this and that for us to look. So first I'm going to do A union B. A union B mean everything in A and B. So there's a 1, there's a 2, there's a 3, there's a 4, there's a 6. Correct? Check it out. 1, 2, 3, 6, 2, 4, 6. So 1, 2, 3, 6, 2, 4, 6. Take everything that are in both of them, but don't take the repeat 2. So you got 1, 2, 3, 4, 6. Then now I'm going to do A union C. So now I'm looking at A and C right there. A is 1, 2, 3, 6. C has 4, 5. So union mean everything in both. So A union C would be 1, 2, 3, 4, 5, 6. take everything in both sets. 1, 2, 3, 4, 5, 6. Now the next step. They want us to make an intersection between those two. So A union B intersect with B union C. All right? So now we're talking about intersection. Intersection. Intersection means only the one in both of them. So let's take a look at these. What's in both of them? 1, 2, 3, 4, and 6. And we count the 5 out because the 5 is not in both. Therefore, in this set, you would have a 1, 2, 3, 4, and 6. And that would be the final answer for this question. All right. Again, if you don't understand, go back and forth to this question and try to understand it. All right, step by step. I think I explained it really well in there. Okay, everybody's good? I'm going to take all the highlight out so that your note doesn't look so bad. Okay. All right. Let's go to number 3. We want A bar intersect with B union C. So I'm going to do A bar first. A bar is everything that's in A as in the universal set, but not in A. So universal set have 1, 2, 3, 4, 5, 6. A has 1, 2, 3, 6. You ready? So let's list the one that's in A bar. A is 1, 2, 3, 6. Universal is 1 through 6. So A1 already in the universe. 2 already in. 3 already in. 6 already in. So that leaves me 4 and 5 for the A bar. Just 4 and 5. Everything else, 1, 2, 3, 6, already in A. So A bar is the leftover 4, 5. Then next, I'm going to do B union C. All right. So B union C is everything in B and C. If you look, 2, 4, 6. And then there's a repeat 4 we don't take. So 5. So 2, 4, 6, and 5. So on this set, you would have 2, 4, 5, and 6. That's B union C. All right. So then A bar intersect with B union C would be. Intersect mean only the thing that they have the same. So intersect, they have the same 4, they have the same 5. So since both of them have both 4 and 5, the intersection set would have 4 and 5. And that is the final answer that we are looking for. I do that to the final answer so you know that is. Okay, let's tackle the last one. The last one, it says B union A intersect C bar. Oh, okay. So to find A intersects B bar, you need to know A intersects C first. So I'm going to take the time to write things down. A because I like to be able to highlight it so you can see things clearly. A is 1, 2, 3, 6. And C is 4, 5. So right now, what I want to do is I want to do A intersect C. Before you can find the bar, you should do the normal one. So let's see. A intersect C would be the thing that's in both A and C. And there is nothing. There's nothing. In A you have 1, 2, 3, 6. In C you have 4, 5. So it is a null set. A intersect C is the null set because there's nothing the same in A and C. Thus, A intersect C bar would be everything else that you see in the universal set. So 1, 2, 3, 4, 5, 6. Because A is a null set. Okay, A intersects C because A intersects C is a null set. The complement of A intersects C would be the universal set, everything in there. Then we want to do B union A intersect C bar. So let me squeeze the B underneath here. B is 2, 4, 6. We want the union of these two sets, right? We want the union of those two sets. Thus, we want everything in both sets except for repeat. Okay, so let's write it down. You know what? I'm going to write it down a little bit down further so that it looks clearer. We want B union A intersect C bar. So look into the two set. Yeah, 1, 2, 3, 4, 5, 6. Wow, all these are in there. So we don't repeat it. So basically this would be 1, 2, 3, 4, 5, 6. Every single element in the universe would belong to B union A intersect C. All right? So it's a little bit confusing to begin with, but if you take your time and you're being very careful, you should be able to do these. Make sure you go over the recording over and over again. If you don't truly understand it the first time, second time it will become clearer. All right? Make sure you do your homework, please, and thank you.